Crash Coursable Chapter 18, where we teach you about air pollution. Air pollution is the presence of chemicals in the atmosphere in concentrates high enough to harm organisms, ecosystems, or human-made materials, or to alter the climate, both natural and human sources. Primary pollutants are harmful chemicals emitted directly into the air from natural processes and human activities. Secondary pollutants are formed when primary pollutants react with one another and the basic components of air. Some major air pollutants are carbon, nitrogen oxides, nitric acids, sulfur dioxide, and sulfuric acid. Industrial smog consists of unhealthy mix of sulfur dioxide, suspended droplets of sulfuric acid, and a variety of suspended solid particles. Not a problem in most developed countries where coal and heavy oil are burned only in large power and industrial plants with reasonable good pollution control, or in facilities with tall smokestacks that send the pollutants high into the air. Industrial smog remains a problem in industrialized urban areas of China, India, Ukraine, and some other Eastern European countries, where large quantities of coal are still burned in houses, power plants, and factories with inadequate pollution controls. Photochemical smog is a mixture of primary and secondary pollutants formed under the influence of UV radiation from the sun. The formation of photochemical smog begins when exhaust from morning commuter traffic releases large amounts of nitric oxide and VOCs into the air over a city. Pollution. Natural factors help reduce outdoor air pollution. First, particles heavier than air settle out as a result of gravitational attraction to the Earth. Second, rain and snow partially cleanses the air of pollutants. Third, salty sea spray from the oceans washes out many pollutants from air that flows from land over the oceans. Fourth, winds sweep pollutants away and mix them with cleaner air. Fifth, some pollutants are removed by chemical reactions. There are also other factors that can increase air pollution. For one, there are urban buildings that slow wind speed and reduce the dilution and removal of pollutants. 2. Hills and mountains can also reduce the flow of air in valleys below them and allow pollutant levels to build up at ground level. 3. High temperatures promote the chemical reactions leading to formation of photochemical smog. 4. Emissions of VOCs, or otherwise known as volatile organic compounds, from certain trees and plants in heavily wooded urban areas can play a large role in the formation of photochemical smog. 5. The so-called grasshopper effect, which occurs when air pollutants are transported at high altitudes by evaporation from winds and from tropical and temperate areas to the atmosphere of the Earth's polar areas. 6. Temperature inversions can cause pollutants to build up high levels. During daylight, the sun warms the air near the Earth's surface. Warm air can temporarily lie atop a layer of cooler air near the ground, creating a temperature inversion. Because the cooler air is denser than the warmer air above it, the air near the surface does not rise and mix with the air above. If this condition persists, pollutants can build up to harmful and even lethal concentrations in the stagnant layer of cool air near the ground. Acid deposition, or otherwise known as acid rain, is the falling of acids and acid-forming compounds from the atmosphere to the Earth's surface. Some harmful effects of acid rain include damaging statues and buildings, contributing to human respiratory diseases, and it can also leach toxic metals such as lead and mercury from soils and rocks into lakes, which can then be used as sources of drinking water. Indoor air pollution is the world's most serious air pollution problem, especially for people in poverty. Levels of 11 common pollutants are generally 2 to 5 times higher inside U.S. homes and commercial buildings than they are outdoors, and in some cases they can go up to 100 times higher. Second, pollution levels inside cars in traffic-clogged urban areas can be up to 18 times higher than outside levels. Third, the health risks from exposure to such chemicals are magnified because most people in developed urban areas spend 70 to 98% of their time indoors or inside vehicles. Some inside air pollutants include chloroform, formaldehyde, tobacco smoke, nitrogen oxides, carbon monoxide, and so on. Some natural defenses against air pollution include mucus in the lining of the upper respiratory tract, hair in the nose, the act of sneezing or coughing. Some harmful health effects from this pollution include asthma, chronic bronchitis, emphysema, lung cancer, heart attack, and even a stroke. To prevent motor vehicle air pollution, we can walk, bike, use mass transit, or even improving our fuel efficiency of the cars. To clean up this pollution, we should require emission control devices, inspect car exhaust systems twice a year, and set strict emission standards. For indoor air pollution, to prevent it, we should ban indoor smoking, set stricter formaldehyde emission standards for carpet, furniture, and building materials. For cleanup or dilution of indoor air pollution, we can use adjustable fresh air vents for workspaces, circulate air more frequently, circulate a building's air through rooftop greenhouses, or even using efficient venting systems for wood-burning stoves.
There are many issues about air quality throughout the world. China has 90% of their cities do not match air quality control
Safety standards, and only 8 of its 74 large cities have officially met the air quality standard. This is an increase from only 3 cities in 2013 compared to the 8 that met the standard in 2014.